Hello, everyone, and welcome to the Monitor Modern Application, the Manage Open Source Way session. My name is Marc Chene, and I lead product and engineering for some of our open source observability services at AWS. I've been at AWS for the last 5 years and was a key influencer in building the strategy and delivering the open source services I'll be talking about in this session. This has been an excellent journey, and I continue to be amazed by AWS's customer obsession, the scale at which we operate to meet customer demand, and our operational excellence. In today's session, I'll be covering the following. What is open source observability and why managed by AWS? I'll give you an overview of some of our open source observability services that I'll be covering today. And then I'll do a latest update for some of our open source services in terms of features that we've also launched. All right, talking about modern application complexity. The complexity situation in modern application is very different. Complexity shifts to a different area when a monolith is migrated to a microservices architecture. In fact, you can easily end up with a several times higher complex environment if you do not plan correctly. There are many moving parts in a microservices environment than in a monolith or a service-oriented architecture. All of a sudden, complexity spikes from 1 to n to the power of n. In the age of microservices and containers and ephemeral workloads, it's easy to spin up and spin down resources. These resources generate a large number of labels, key value pairs, that are used to help detect and isolate problems faster. The most important thing we do as part of our operational excellence culture at AWS for the services that we operate is to continue to reduce the time to detect problems and recover as quickly as we can to ensure our customers have minimal to no impact. No single area has seen more open source innovation than containers, with the wide adoption of projects such as Kubernetes, Prometheus, and open telemetry. Let me move on to some of the open source services that my teams use at AWS to help with detecting and isolating problems faster. So in this session, I'll highlight 3 of the open source services that gives our customers choices in how they can monitor and observe their modern applications. First, I'll talk about Amazon Managed Grafana, a rich data visualization service for viewing all your operational data, including metrics, logs, and traces. Second, I'll talk about Amazon Managed Service for Prometheus, a managed monitoring and alerting service for containerized applications and infrastructure metrics. Third, I'll review AWS Distro for Open Telemetry, ADOT, a portable set of SDKs, libraries, and agents that are secured and supported by AWS. Other observability services used by our customers and internal AWS services teams include CloudWatch and OpenSearch. As part of this event, Surabhi, Ashok, and Graham already talked about CloudWatch, which is AWS's cloud-native observability service. The OpenSearch project is an open source software that is community-driven and offered as a managed AWS service. OpenSearch makes it easy to ingest, search, visualize, and analyze logs and trace data. The one call out I want to make is that customers, including my own teams, commonly rely on more than one observability service. Grafana in this case, can be used to visualize and correlate tools as a tool of choice for your metrics, logs, and traces, regardless of where your observability data is stored, including CloudWatch and OpenSearch. The modern apps engineers can rely on these AWS open source managed services to continuously operate, monitor, and scale short-lived and high cardinality containerized applications. Prometheus and Grafana are often used by engineers as their open source tools. They are highly optimized for container environments, and they can be used in AWS and hybrid environments. One of the most common questions I get about AWS and why should I use managed services are the following 4 areas. And this is how I answer to these questions. First, the reason why you would want to adopt managed services is security. We offer a secure way of integrating with AWS services such as identity access management control for authentication and authorization, and ensure that all your data is encrypted in transit and at rest. Security also includes patching security vulnerabilities, meeting your security compliance needs, by auditing who's accessing the service and the APIs, and complying to general data protection regulations, all things that we take care of with all these managed services. The service also automatically scales to meet the demand of our largest enterprise customers, eliminating the need for you to over-provision and optimize the underlying infrastructure. We also provide high availability across multi-availability zones for our managed services. We provide integration with several AWS services, including builder tools such as CloudFormation, Cloud Development Kit, and we also integrate with several other services like CloudTrail for auditing, Private Link for making sure that all your traffic is secured within the network, within the AWS network without going on the public internet. But one of the reasons why I also started these services or influence in building some of these services is primarily around the open source contributions. We also contribute back on the open source communities and collaborate with special interest groups to represent the voice of our customers. This is one of the important reasons why I continue to do this, and I really enjoy doing this at AWS. At AWS, we really love open source. Our teams and my teams are always thinking about how we can improve the lives of our builders and the community that are using and building on open source technology. Amazon is the top 12 contributor in Open Telemetry project. Some key contributions include collector tracing and metric stability, including improved Prometheus interoperability. We have 3 Cortex maintainers at AWS, and Amazon is the #1 contributor to this project in the last year. For the last 3+ years, we have partnered with the Prometheus open source community, working closely with contributors and maintainers of Cortex, Thanos, and Prometheus open source projects by running tests and contributing code and finding to help scale and increase availability and stability of these projects. In 2021, AWS and the open source community created OpenSearch. This project has exceeded 100 million downloads since launch. AWS led over 10+ releases and 100+ features in the past year. Some of the marquee features include the adoption of Lucene 9, observability features with support for logs, metrics, and traces, and semantic search. Amazon is also continuously prioritizing new Grafana plugins, updating existing one, and triaging issues for plugins such as CloudWatch, Athena, OpenSearch, and many more. Amazon is also the 4th largest contributor of FluentBit and Fluentd. Some key contributions include continuous stability and performance testing, priority event loop for performance improvements under high load, and multi-line filter features. It is important for AWS to continue to be thought leaders and good stewards of open source and open standards. We play an active role and plan to do much more. Let's now dive deeper into some of our managed services. A well-created graph, map, or pick your favorite visualization gives engineers an easy way to understand the data and expedite decision-making. It also gives you a concrete foundation to back up a point that you may be trying to make. Not everyone is an expert in understanding how to query or analyze data. So a tool that allows you to create pre-built dashboards by someone who is a subject matter expert and then share it broadly ensures that the data can be understood and interpreted correctly. So how can you combine these 2 practices in your organization by leveraging AWS services? What if you could use a single data visualization tool to democratize both operational and business data across your organization, whether you're an IT operator, a developer, a marketing and business user? Grafana is a popular open source data visualization tool that enables you to query a wide breadth of data types, whether it's operational or business, in a single interface. The beauty of Grafana is that you can query data regardless of where it's stored, so you can build your operational and business data lakes. On AWS with services such as Prometheus for operational data and AWS Lake Formation, S3, and Athena for business data. You can leverage Amazon Managed Grafana to centralize all your data querying, reporting, and dashboarding needs. It's not just AWS services that you centralize your querying. You can also combine it with your on-premises databases that you might still be self-managing, such as SQL, or even combine it with data from third-party ISVs, such as ServiceNow, Atlassian, or your vendor of choice for operational monitoring, and even data from other clouds. With Grafana, you don't need to context switch between querying data in one interface and then switch in another tool anymore. You can bring a single view across your infrastructure, application, organizational, and business health. All right, let's go through it and talk a little bit more about our next service, Amazon Managed Service for Prometheus. Prometheus enables real-time alerts and monitoring optimized for high cardinality and high volume time series metrics. Common use cases include unified container monitoring, troubleshooting and root cause analysis, and workload and application monitoring. The serverless service automatically scales as your ingestion storage, query, and alerting needs grow, handling millions of unique time series metrics from large container deployments running on AWS and hybrid environments while maintaining fast query response times. Managed Prometheus is fully compatible with the Prometheus data model and Prometheus query language PromQL. Prometheus provides a flexible query language for aggregating metrics across high volume labels, key value pairs. The Prometheus service makes it easy to import your existing Prometheus configuration, such as recording and alerting rules, to pre-aggregate an alarm on metrics. The Alert Manager allows you to create, group, and inhibit alerts. You can also use it to deduplicate, silence, and route alerts to Amazon Managed simple notification service, and then send that to a destination of choice or by email to your engineers to notify them when an issue is occurring. Let's move on to OpenTelemetry. So ADOT is a downstream distribution of the OpenTelemetry Cloud Native Computing Foundation project. OTel is the open source project that standardizes APIs and SDKs in over 11 plus languages for instrumentation and collection of telemetry data. It provides an open standard way in how your applications running on containers, EC2, or serverless environment can be instrumented and produce telemetry that you can store in Prometheus, in CloudWatch, and in OpenSearch. ADOT provides a production-ready distro with predictable performance and components backed by AWS support that we update on a monthly cadence. Recent contributions include support and stabilization for the group by and tail-based sampling. We just announced it in May of this year. This allows you to apply tail-based sampling for traces with the ADOT collector to now control the volume of traces ingested in supported services such as AWS X-Ray and OpenSearch. Let me walk you through an architectural review of the open source services and how it all comes together. The following diagram provides an overview of what makes up the end-to-end observability solution for instrumenting, collecting, storing, and visualizing your metrics. First, a collection agent, here on the left, such as to OpenTelemetry, is used to discover, scrape, and securely write your metrics or your traces to a compatible backend. In this case, we'll do metrics in a Prometheus workspace in any region of your choice. A workspace is simply a logical and isolated space dedicated to the ingestion, storage, alerting, and querying of metrics from one or more Prometheus server. You can have as many of these workspaces as you want in any of the AWS supported regions. So it gives you a little bit more access control depending on if you want to have it per team control on the data, or what we see as a common practices is that across multiple clusters, across multiple regions, across multiple accounts, customers tend to want to centralize all that data into one workspace. Let me now share some of, and the last but not least, of course, is Amazon Managed Grafana. So data can then be securely queried using the Prometheus compatible APIs, including those supported by the Prometheus data source plugin available in Grafana. PromQL helps you create that powerful and flexible language and simplify the querying and finding isolated versus systemic problems across all your operational metrics. All right, let me talk to you a little bit more about some of the new services or new features that we've announced for some of these services. All right, so there are 3 themes that we've prioritized in 2023 based on customer feedback, which include security and compliance, scale and region expansion, and single pane of glass or unified experience, which is really an opportunity for us to unify all of the sources of telemetry experience and simplify how we onboard, instrument, and collect data required for visualization. Since we launched Managed Grafana and Prometheus over 3 years ago, we've been listening to our customers' needs and continue to improve around our core pillars, such as furthering security features, including SOC, ISO, and PCI certification. We added new security features recently in Grafana, including workspace network access control. So this enables you to further secure the rollout of Grafana workspaces with customer-managed prefix lists and VPC endpoints to restrict the inbound network traffic to these workspaces. At reInvent in last year, in 2022, we announced private VPC data source. We now support connecting to data sources inside your Amazon Virtual Private Cloud, so Amazon VPC. Customers, that's been one of our most popular product feature requests that customers have been asking for. So these it gives you the ability to connect to data sources that are not publicly accessible. This includes, as an example, OpenSearch service clusters, Amazon RDS instances, self-hosted data sources, and other data-sensitive workloads, often that are not privately accessible. So Amazon Managed Grafana can now securely connect to private VPC data sources while maintaining a strong security posture. Scaling and region expansion at AWS is a continuous journey. Managed Prometheus supported 21 million active time series metrics per workspace when we first launched general availability in 2021. We continuously iterated to scale up the number of metrics in 2023 to 80 million in July and 200 million in December that we announced at reInvent. In March of this year, we announced support for 500 million active time series metrics per workspace and expanded the number of rules you can support per workspace to 30,000. That is an increase of 20 times greater, more metrics per workspace since we launched. Customers can create as many workspaces as required per region, enabling the storage and analysis of billions of Prometheus metrics. Similarly to our scale journey for Prometheus, Managed Grafana now supports up to 10,000 provisioned and 500 concurrent users per workspace to visualize and alarm on all of their data. Let's go on to the last theme around a single pane of glass and unified experience. So a couple of things that we've announced recently is centralized alert management. So it's supporting that unified alert capability from Grafana to be able to create multi-dimensional alerts in a Grafana workspace. We've also added support for Prometheus rules in Grafana. So you can now visualize and analyze your alert manager rules, alert states, you can silence your alerts, and contact points directly in Managed Grafana. We talked about private VPC already. I'm not going to mention that one again, right? Bringing all these sources of data together in Grafana, even if they're on your private VPC. OpenSearch Trace Analytics, that's something that we've just announced. Using this, the existing OpenSearch plugin, you can now visualize traces stored in OpenSearch that show the timeline of trace spans, enabling you to isolate the source of performance problems and diagnose their root cause directly from Managed Grafana. You can now bring together logs and traces data stored in OpenSearch and easily correlate them with metrics stored in Managed Prometheus in a single dashboard. Last, who here is being asked to manage their infrastructure and application costs? I certainly am. I'll ask that every month, right? How can we reduce cost? Last year, we released support for and visualize your AWS spend through the Amazon Athena plugin in Grafana with default dashboards to query your AWS cost usage report. This includes the ability to also track your Kubernetes control plane and EC2 costs. As you modernize your applications and deploy workloads using Amazon EKS, you gain efficiencies by consolidating the compute resources required to run your applications. However, this utilization efficiency comes at a trade-off of increased difficulty measuring application costs. In September 2022, we announced Cube Cost collaboration with AWS to deliver cost monitoring in EKS that allows you to collect, ingest, and analyze your cost across one or all your clusters in Amazon Managed Service for Prometheus. No presentation is completed without a demo. To save some time here, I've set up some of the EKS clusters and some of the services already, like Prometheus and Grafana. And I'll show you how easily it is to install and sample app with instrumentation and collect data to send to Prometheus and monitor it in Grafana. It uses Terraform, an open source infrastructure as code tool that I'll use to deploy AWS distro for open telemetry over here in my cluster for collecting the data as an EKS add-on. So that's how that's going to be deployed. and some opinionated EKS infrastructure monitoring and Java dashboards and alarms to monitor the workloads running on EKS. I'll deploy this on Grafana. So we already have Prometheus, as I mentioned, and Grafana. So let's go ahead and do this. So if you're just getting started with these open source services, this workshop will really make it easier for you to get started, even if you're a veteran. I mean, it's a good way to get started. It'll take you less than 30 minutes. Follow the instructions. We'll do the infrastructure here in the Java monitoring. And within less than 30 minutes, you'll get this all up and running. Unless you're like me, of course, and you got to update everything like Homebrew, Python, AWS SDK. But other than that, it won't take you that long. All right, so let's go ahead and get started by first going ahead and making sure that I'm in the right directory. Again, I'm just going to follow the instructions here and make sure that all these variables are set. So all the variables are in this this tvars file, so this variable file that's going to be used by Terraform. I put the name of my cluster, the region where I'm deploying, the workspace ID. I'm not going to put in the Grafana API key. I'm going to go ahead and set that directly in the terminal I'll be working in. It expires frequently enough, so you just got to update that before you run these modules, so just note that. All right, so we're in the right directory. I will go ahead and do a Terraform init, make sure that everything's set up. And then I'll go ahead and set my API key and just reuse the command that I've used recently. So if I type this in manually, I will make a mistake. And then what I'll do next is I will go ahead and apply the file as for file equal demo. I think I call, there you go. And I think that will be it. This will start applying it, then they'll be asked to accept all the updates that the module will deploy. And then we'll go ahead and look in the console. So this is the AWS console for my account. I got my Grafana, my Prometheus service. Time permitting, I might drill a little bit into these services. So for Grafana, I have my workspace here already created. Again, I use the same modules here. And I'm going to go click on that in a minute. But before, I'll go ahead and start the deployment. So here, when I click on the workspace, I can launch. I'm using single sign-on. You can set up your own identity provider, so such as Okta or anything else. Here I'm using AWS SSO. Dashboards are already starting to be deployed. Great. So this gives me the view of my workspace. My collection is going to be installed, my ADOC collector, and I'll be able to start monitoring these dashboards. So just to give you an idea, so the default when you install, I believe, Prometheus or Grafana, you'll get to see the dashboards, see how many metrics are coming in, some of the workspace ingestion, and this will obviously change over time when I add more metrics. And as this is happening now, I'm just going to give it a minute or so to be able to see the data come in. What I'm going to show you is the console. So again, this is where you would set up your IAM Identity Center. I set up the AWS one. You can use your own SAML configurations if you want. These are the data sources that you can configure. We have 8 data sources today and more to come. This shows you that it's attached and enabled in the workspace. So I have the Prometheus, CloudWatch, X-Ray, and you can configure them directly. This will also automate the installation and permission management, so you can query these APIs from these services that are required. And then there's some more features and network access control for security reasons and tagging as well. You can go look at that and look at some of the documentation. All right, so now that my module is still being deployed here, we'll wait a few more minutes. Give it some time. It shouldn't take another 30 seconds or so. Let's go look at the Prometheus service as well. So Prometheus, again, pretty straightforward. Go to the Prometheus service, get there eventually. Here you go. And here you'll see you can create a workspace. It literally takes under a minute to create a workspace where you can start setting the data. So this is the workspace that I'm using. Get to see instructions on how to manually install it, or again, you can use the Terraform module, which is what I'm using. These are some of the rules, aggregation rules and alerting rules that are deployed with this workshop. And then you can set up other areas that you have here. All right. So that should be completed by now. Perfect. If I do a quick check here to make sure that everything has been properly deployed. Get pods, we'll do all namespace for now. This should have deployed a ADOT collector, fire, fluid bit. Okay, so perfect, that's done, that's done. And that's really what I want from within the cluster. These are the list of applications, all and also deployed the exporter, so one on every node. The node exporter is what gives me my infrastructure metrics. And that's it. So now if I go and click on my, let's start with the infrastructure monitoring. We'll go ahead and look at the cluster ones. I'll go ahead and select the data source. And there you go. So these are examples of some of the metrics that are coming in. For the environments, the metrics are just starting to come in now, so you're going to start seeing these numbers being populated. And the same thing for Java. Go ahead and select the Prometheus workspace. And again, same thing here. You're starting to see the metrics come in from Java. All right. I think that is it. This is what I wanted to show you. Again, look at this module. Great place to start. If you're not running any applications, you can start off with a new cluster. It'll actually even set up an EKS cluster if you want. This will also give you sample applications that you can run in your cluster to monitor them, to give you an idea of how these metrics are being scraped and how that also does with some load generation. All right, so that's it for my demo. So again, as an administrator, you'll get to see all of the capabilities from Grafana, including alerting capability, Explorer to be able to make some ad hoc queries, and the ability to manage all these data sources that you have. You can integrate with the alert manager from Prometheus, or with the managed service for Prometheus, be able to view all the rules that are defined that are deployed with this module and which rules are firing as well. I hope you enjoyed this in the presentation and some of the content that I shared with you. I shared the benefits of 3 of the open source observability managed services. Amazon Managed Grafana for your rich data visualization, Amazon Managed Service for Prometheus for your high cardinality time series metrics, and last, AWS Distro for Open Telemetry for instrumentation and collection of metrics and traces. So what's next? Well, here's your chance to go ahead and look at our services, look at our blogs and our service pages to learn more about our services. But most importantly, I'm leaving you here with a bunch of resources where you can do this at your own pace and try it out for yourself. Very easy to get started, and hopefully that you'll enjoy some of our open source services. Thank you.